Suppose the inflation rate averages 6% per year for each year from 2000 to 2010. This means that an item that costs $1 one year will cost $1.06 1 year later, and the second year, the 106 cents cost will be increased by the factor of 1.06 again, so it'll be 1.06 squared. We want to write an expression that gives the cost t years after 2000 for an item costing $1 in 2000. Well, we're using the form, this is going up, so we're using the form y equals a times 1 plus r to the t. So y will equal, a is $1, that's the initial value, and then it'll be 1 plus 0.06 to the t, which can be defined as y equals 1.06 to the t. And this would be our expression. Now we want to do the same thing, but we're writing the exponential now. The item costs $100 in 2000. So it's very similar, but y equals a is now 100 times 1.06 to the t. So this becomes 100. And we want to use that model to find the cost of the item from part B in 2010. So now t will equal 10. Y will equal 100 times 1.06 raised to the 10th. And when I grab my calculator, I will find out that this is 179.0847697, which of course it's money, so it'll be $179.08 for my solution. This table shows the average poverty thresholds for one person for selected years from 1990 to 2005. Note here, when using technology to fit a logarithmic model to data, you should align the data so that all the endpoint values are positive. That means they must be greater than 0. You cannot have even 0 as one of the numbers. So we enter the data into the table, making sure we make no mistakes, because one digit wrong will give you the wrong equation. I entered correctly. Let's find the function. So we'll go to Stat, Calc. We're looking for a logarithmic equation. So that's an ln. There is not a ln regression. There's not a log regression. It'll be an enter. We will want to save this in case we need to use it. So save it to yvars in our normal manner and go down and calculate it. And y equals negative 2,179.067 plus 3,714.021 times the ln of x will be our equation. Now, following along, I showed that with a calculator. Y equals negative 2,179 and 67 hundredths minus 3,714 and 21 hundredths, the ln of x. Sorry, this is a plus, as you know. We found that by going to Stat, Calc, and selecting now 9 It's a logarithmic regression, but it does it to the natural log, so it's the ln regression to find that data. Use the reported model to predict the average poverty threshold in 1997. So X will equal 17 then. And filling that in, Y will equal negative 2,179 and 67 thousandths plus 3,714 and 21 thousandths times the ln of 17. Using the calculator, that comes out to $8,343.55 for the average poverty threshold in 1997. What year does this model predict the threshold to be 10,033? Well, we'll fill in with y1 will be our equation, and y2 will be 10,300. And it turns out that x then, the intersection is at 28.78885, or we can round that x equals 29 plus the 1980, so that would happen in 2009.